All right, so we're back with coal prices. So the average price paid by the syn fuel industry for a short ton of coal between 2002 and 2005 can be modeled as P of T equals 1.2 T squared minus 6.1 T plus $39.5, where T is the number of years since the beginning of 2000. All right, so we're supposed to again use the limit definition to derive the rate of change. So we're going to end up with dollars per year, it looks like, for our derivative. So let's choose a point again. And again, after a while, you're going to understand how this works, and you won't actually have to write all this down. But until then, it's always best to kind of write down the steps as you go. That way you don't skip a step, and you know what's going on. So the point is going to be t comma 1.2 t squared minus 6.1 t plus 39.5. And then that's going to be end. And then our close point can be t plus h, t plus h squared minus 6.1 times x t. I knew I was going to change it eventually. I like x's better, I guess. All right, t plus h, and then a plus 39.5. Okay, now t plus h squared, well, that's going to be t squared plus 2th plus h squared. And so now we can take that times 1.2, so that gives us t plus h comma 1.2 t squared plus, now 1.2 times 2 is going to be 2.4 th, and then plus 1.2 times h squared, and then minus 6.1 times t, and then minus 6.1 h, and then plus 39.5. Okay. Now, can we add things together? We have th. It looks like all of that is going to stay there. So now we need to find p prime of t, which is going to be the limit as h goes to 0 of this whole big thing, 1.2 t squared plus 2.4 th minus this thing. And so that's going to be 1.2 t squared minus 6.1 t plus 39.5. And again, that's all over h. Okay, so let's see if we can get this fit in here. Lemma as h goes to 0 of 1.2 t squared plus 2.4 th plus 1.2 h squared minus 6.1 t minus 6.1 h plus 39.5 minus 1.2 t squared plus 6.1 t minus 39.5. And we see if we can get all this over h. Now let's cancel some stuff. Looks like this will cancel this. 6.1t will cancel 6.1t, and 39.5 and 39.5. And I think that's all. So now I have to remember all that and put that on the next page because I don't have enough room here. And so let's see, we'll have our p prime of t is going to be the limit as h goes to 0 of, now we had the 2.4 th plus the 1.2 h squared minus the 6.1 h. And I think that was all we had left. Make sure here. 2.4, 1.2, negative 6.1 h. Okay. And that's all over h. And so if we factor out a h out of each of those, we get 2.4 t plus 1.2 h minus 6.1, and then that's over our h. Now, if we replace the h over h with 1, that gives us the limit as h goes to 0 of 2.4t plus 1.2h minus 6.1. And if we plug in h is equal to 0, that goes to 0, and we're left with 2.4t minus 6.1. Okay, and so that's what p prime of t is equal to. Okay, now what was our units again? I think it was dollars per year, and so that's dollars per year. So that's our rate for this coal prices here, and so that would be the rate. And now they want to know how quickly was the price of coal used by the synthetic fuel industry growing in the middle of 2003? Well, 2003 is going to be, did we set it since 2000? So it's going to be 3.5. So we want to find uh, p prime of 3.5. What is that going to be equal to? Well, 2.4 times 3.5 minus 6.1. And so if we take our calculator out, which is right here, 2.4 times 3.5 minus 6.1, that's going to be 2.3, and that's dollars per year. Okay, and it doesn't actually ask us to interpret it, but it's going to be, in the middle of 2003, the average price paid by the fuel industry for a short ton of coal uh, was increasing by $2.3 per year. Okay, and that's what it would be, but it doesn't ask for that. It just asks for what does the p prime of 3.5 equal. So that's what that was asking for, and this was part A. Okay, so those are the two things they're looking for. All right, so let's see. Let's go ahead and do the next one here. And so it says tuition CPI for the CPI for all urban consumers for college tuition and fees between 2000 and 2008 is given by this here table below. Okay. Now we need to find a model for the CPI with the aligned input of t equals 0 and 2000. So, this is 0, 1, da, 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 and all the way down to 8. Okay. Round the coefficients of our equation to 2 decimal places. So that's a key. We only want 2 decimal places in our equation. And then we use the algebraic method to develop a formula for the derivative of the rounded model, evaluate the rate of change of the function in part A for the year 2005. So basically when you want to have t equals 5, and then interpret that result, and then calculate the percentage rate of change in CPI in 2005 and interpret our result there. All right, so what we need to do is go plug this into our calculator. So let's go to the calculator, and what we have now is we have to put that in. And so I was nice and typed it in, so you didn't have to watch me type it in. But now what we have to do is we have to figure out what it looks like. All right, so looks like it's a straight line. Now, is it a straight line? Who knows? Let's look and see. 4, and then let's go down. Let's put that into vars 1. Oops. Okay, well, now let's say vars 1. So now we can do that. 0.999, that's pretty good. It's going through all the points pretty close except for that one. So either I typed a number wrong, or that's just kind of the number how it's supposed to be. So let's look and make sure my numbers are right. 331.9, 361.9, 387.4, 425.5, 462.2, 492.8. Well, they all look right. So we're going to go that it was just a bad number for that point here, and it was just low compared to the rest of those. Okay. And so what does that give me for my regression? So I need to have that. That's really the key here. So 32.97x 328 point, if we're going to 2 decimal places, 0.10. Okay, so that's what I need. So let's go back over here. And so our it was a linear model, and it was going to be, let's call it C of t was equal to, and we saw it was about 32.97x, and then it was plus 328.10. And that's going to be the CPI for year T. Okay, so that was our function, and so now we're supposed to use the algebraic method to develop the formula for the derivative of the rounded value. All right, so again, I use T and X in the same function. So let's erase the X and put a T. All right, so now I need to find a point close, or a point and a point close. So that's going to be T and 32.97t plus 328.10. And then the close point is going to be t plus h, comma, 32.97. And then it's going to be times t plus h. So I'm going to think about this as I'm going to just go ahead and distribute it here. So it's going to be t, then plus 3.97h, and then plus 328.10. So I'm kind of doing the algebra kind of in one place, so then I didn't have to do another step here because there's not a lot of room here, and I don't know how much I need to then remember on the next page. So I just went ahead and took that t plus h times 32.97, and I got this. All right, so now I'm going to look for C prime of t is going to be our limit as h goes to 0 of, now we're going to have 32.97t plus 32.97h plus 328.10 minus, now if we think about this, it's minus this because it's going to be a minus, that. And when you take a minus times, that's going to be negative. So that's going to be 32.97t. And then it's going to be a minus 3028.10. And again, just kind of trying to save a little bit of writing here. So see if I can get it all on one page, or it'll be less to have to write on the next page anyway. All right, so I have 3297t here and a negative here, positive and negative here. And so it really only comes down to that part right there. Okay, so that's not too bad. And so that says the limit of h goes to 0 of 32.97h over h. Well, our h over h is going to go to 1. And so this is just the limit as h goes to 0 of 32.97. Well, a limit of just a number, well, guess what? We just get 32.97 out, okay? And 32.97 what? Well, it's 32.97 the CPI per year, okay? So your consumer price index per year. That's going to be our rating for a year, okay? Now, if we were actually doing this in a real life, we wouldn't want around to just the 2 decimals. So that's just to make it so we can get to something easy, and that's going to be the key here. Now, what does it say? Evaluate the rate of change of the function in part A for the year 2005. All right, so we go over here and we're going to say C prime of 5 equals 32.97. And, there was no t here, so the rate of change at 5 or 4 or 1 or anything is going to be the same. It's going to be our CPI per year, our number for CPI per year, okay? And so it said interpret, so we can say in 2005, the CPI for, what was it, college tuition? Yeah, college tuition. And fees it's going up, increasing by 32.97 per year, okay? Now, what we need to do is we need to actually calculate the percent rock, I believe. Okay, and so what we need to do is we need to do some calculations. So let me get my calculator out here, and we're going to take our percent rock is going to be our C prime of 5 over our C of 5 times 100%. Okay, well, C prime of 5 we found was 32.97. And now we have to plug in 5 into this equation here. So it's going to be 32.97 times 5 plus 328.10, and then times 100%. And so if we do that, we get 32.97 divided by 32.97 times 5. So I get 6.688. So it's going to be approximately 6.688%. And probably I'm going to round this to 6 point, maybe at the most 69%, because get the 2 decimal places. So I would say that would be the thing. And so what we could do there is say in 2005, the CPI for college tuition and fees was increasing by 6.69% per year. Okay. And so that would be my value there. Okay. And again, a lot of it really comes down to doing the algebra. Can you do the math? Can you take, t plus h times t plus h, or, that one we had to take it t plus h and cube it. Can you do that? And then after that, you just reduce it, and then you just continue on until you get down to your final derivative. In this case, it was just 32.97 was our final derivative. And then we plugged in everything from there to get our C prime of a number, 5 in this case, and also our percent rock. All right. And that's all I have for this section.